Our lesson today is angle of elevation and depression. Angles of elevation and depression. Objective: how we can use angle of elevation and depression to solve problem. In the opposite figure, we have the angle of depression and the angle of elevation. What is meant by the angle of depression and the angle of elevation? Now, we have to know the meaning of angle of depression and the angle of elevation. Firstly, you have to know the angle of elevation. Angle of elevation. The angle of elevation of an object as seen by an observer is the angle between the horizontal and the line from the object to the observer. The line of sight. The angle of elevation of an object as seen by an observer is the angle between the horizontal and the line from the object to the observer eye, which is called the line of sight. In our figure, here we have the object and the observer eye. The line joining between the object and the observer eye is called the line of sight. The line joining between the object and the observer eye is called the line of sight. The angle included between the horizontal line and the line of sight is called the angle of elevation. Again, the angle of elevation of an object as seen by an observer is the angle between the horizontal and the line from the object to the observer eye, the line of sight. Again, the angle included between the line of sight and the horizontal line is called the angle of elevation. While the angle of depression, if the object is below the level of the observer, then the angle between the horizontal and the observer line of sight is called the angle of depression. If the object is below the level of the observer, then the angle between the horizontal and the observer line of sight is called the angle of depression. As in figure, we have the line of sight and the horizontal line. The angle included between the line of sight and the horizontal line is called the angle of depression. The angle included again between the line of sight and the horizontal line is called the angle of depression.
I was walking through the forest when I came upon a tree. I began to wonder, how tall can it be? So Katoa, how tall is that tree? But I only have a ruler and a protractor with me. I backed up 20 feet, then looked up at the tree. My protractor said the angle was 58 degrees. So Katoa, oh, how tall is that tree? I know the edge is 20 and the op's a mystery. Decide I'll take the tangent of 58 degrees. The fourth decimal place answer is 1.6003. So Katoa, oh, how tall is that tree? I'll use my calculator to solve this mystery. So x over 20 is 1.6003. With cross multiplication, I'll find x, wait and see. So 32 feet tall is the answer that I found. And I'll also add the distance from my eyes down to the ground. So Katoa, oh, how tall is that tree? Well, 5.5 plus 32 will solve this mystery. So Katoa, how tall is that tree? I can find the answer with trigonometry.
Now, we have some examples for elevation angle. Bob is standing 80 meters from the base of building. When he looks up at 25 degree, he sees the top of the hill. What is the building height? Bob is standing 80 meters from the base of building. Bob standing 80 meters from the base of building. When he looks up 25 degree, which means angle of elevation equals 25 degree, he sees the top of the hill. What is the building height? What is the building height? We have the height is the opposite side to the angle of elevation. The height is the opposite side to the angle of elevation, while the distance from the base is the adjacent side. So by using tangent rule, we have tan 25 equals height over 80. Tan 25 equals the height over 80. By using calculator, tan 25 equals 0.466 equals the height over 80. Cross multiplication, we have 0.466 times 80 equals the height. The height equals 37.3 meters. Another one. Pair sits on the top of lamp post. The angle of separation from the pair to the feet of an observer standing away from the lamp post is 35 degrees. The lamp post is 14 feet tall. How far away is the observer from the pair? How far is the observer from the pair? By drawing, we have the bird and the lamp post. The angle, the height equal 14 feet. The angle of depression 35 degree, which equals to the alternate angle 35 degree. By applying sine rule, we have sine 35 equals 14 over x. Sine 45 equals 14 over x. Why? Because 14 is the opposite side to 35, while x is the hypotenuse. 14 is the opposite side to 35, while x is the hypotenuse. So by applying sine rule, which sine equals opposite over hypotenuse, we have sine 35 equals 14 over x. By using calculator, we have sine 35 equals 0.574. Cross multiplication, we have 0.574 times x equals 14. Then equals x equals 14 divided 0.574. X equal 24.4 feet. Finding the angle. An airplane is flying at a height of 2 miles above the ground. The distance along the ground from the airplane to the airport is 5 miles. What is the angle of depression from the airplane to the airport? From the drawing, we can apply tangent rule. Then the angle of elevation will equal 2 over 5. By using calculator, we can find the measure of the angle of elevation.
Class, this video is on angles of elevation and depression. Now, before we start getting any further, really and truly, the simplest way to put it is angles of elevation and depression is a way for us to solve problems, geometric problems, using sine, cosine, and tangent in a word problem form. Instead of just spouting out and getting a bunch of problems with triangles and solving this and this, angles of elevation and depression is a lot of ways to apply trigonometric ratios and trigonometric problems into a real-world application. And so since we do that, we have special names for angles of elevation, angles of elevation and angles of depression. Now the angle of elevation, if we're looking at our particular picture here, we have an observer down on the floor or down on the ground looking up at a person or a balloon, a hot air balloon, and we can see that an angle, as we're looking, the angle of elevation of an object as seen by an observer is the angle between the horizontal and the line from the object to the observer eye, which is the line of sight. If we are looking at this particular one, we have the horizontal here, and the line of sight is up to the hot air balloon. So with the horizon here up to here, we have that angle of elevation. Now with the angle of elevation drawn, we see that it's 38 degrees. Also, if the object is below the level of the observer, so if we were up here in the balloon and we were looking down from the horizon, then our angle of line of sight would be angle of depression. So based upon that information, as we're looking at the two horizontal line and with our line of sight, notice that in each case, what have we drawn? We have that connection between the two from the line of sight being a transversal line and with our two horizontal lines as being parallel. Notice that we have alternate interior angles. And the angle of depression is the same as the angle of elevation. So keep that in mind. It's very important that we understand that this observer's angle of depression, as they are looking down at this point, would be this observer's angle of elevation. And they are the same measure. Well, let's go through and let's look at a couple of problems for these. One here we have just a way to look at it trigonometrically and from a real life standpoint. If we're here in a boat out on the water, and as we're here on the boat and we look up and we see a plane, as we look with the horizon, notice as we look up to the plane, we create that angle of elevation. Yet if we're the pilot here, and as we look out with the horizon and look down to the boat, we create an angle of depression. And once again, these two would be the same measure. So the angle of depression would equal the angle of elevation as well. Now let's apply that particular problem. We're off in our little bitty sailboat this weekend, and we look up to the top of a lighthouse, and we see that we're told that our line of sight, and this is our line of sight, is 200 feet. And from that horizon, as being looked down from the lighthouse, and we're being spotted, we see a 23-degree angle. Notice as we are looking here, we have a nice big right triangle with a right angle. So this is an applied property. We have an angle here. That is our theta. So we need to set this up. We're looking for x. Now recall that if we're looking for x, that is the adjacent side. So then therefore the cosine of 23 degrees would equal the adjacent over the hypotenuse. Solving the ratio, we would have 200 cosine of 23 degrees would equal our x. Now, to make sure we put that in the correct way, let's look at it. Here I have my graphing calculator, so I'm going to say 200 times cosine of 23 degrees and enter. We're going to round, because it is a side length, we're going to round to the nearest tenth. Therefore, x equals, oops, I forgot it, 184.1. 184.1. So if we were looking at it in this way, and we could draw this triangle back down this way, that tells us this is x as well, So the sailboat is 184 feet, 184.1 feet away from the base of the lighthouse. And that is an applied problem, the way that we can solve if we're out in the sailboat. Of course, let's look at some more examples. We are an observer or outside, and we're looking at a tree. Common problem. Now we want to know the height of the tree. We want to know the actual combined height of the tree. We're looking for our X here. Now understand where the horizon is. The horizon goes along with our what? Our eyes. Now let's say that this is me standing here. So my eyes are 6 feet off the ground. Keep that in mind. So as an observer whose eyes are 6 feet off the ground, looks up to the top of a tree with an angle of, let's say that that angle is of 33 degrees, and the observer knows that they are standing 100 feet away from the base of the tree. We want to know how tall the tree is. Now we're not solving for X, because X, in this case, we're not solving for X right now. X is the entire height of the tree. We would have to solve for Y to find the height, or the opposite side of this right triangle. And once we find the height, then we know that the height of the tree, X, would equal Y plus the height of the observer's eyes. So that's the reason why we have that 6 feet here. We know that the observer's eyes are 100 feet from the base. So in relationship to our 33 degree angle, we are looking at the opposite of Y and the adjacent of 100. So therefore it is the tangent. 33 degrees equals opposite over adjacent. And once again, since the value is in the denominator, we are going to multiply. So we have 100 tan 33, and that is equal to Y. So we would have 100 times, we don't really have to put that, but times tangent 33. And that gives us a value of 64.9. So Y equals 64.9. But that's not the height of the tree, so we're going to have to add it to it. So we have 64.9 plus 6. So therefore, the height of the tree is 70.9 feet. Moving on, another example. The best way we can do this is just continually working. Looking at it from a different perspective, now we know the height of the tree. And from where we're standing, we are 68 feet away. So from the base of the tree, we're sitting here and we're standing 68 feet from the tree. And we know that the height is 51 feet tall. We want to know the value of X, or let's be consistent. Instead of X, yes, let's use theta. We're looking for theta. So in relationship to our angle theta, we know that we would be using the opposite. We have to write it. Here's the opposite. Here's the adjacent. Here's hypotenuse. So our two values we're given are opposite and adjacent. So that is the tangent function. So tangent of theta equals 51 feet over 68 feet. Now, since we're using, or not using, but solving for an angle measure, we're going to say that theta equals the inverse tangent of 51 over 68. So in order to do that, we go shift or second, depending on your calculator, tangent. Notice it gives us that inverse of 51 divided by 68. And if we want to, we can close and enter. Now, as we discussed a lot in class, if we are solving for an angle measure, we want to round that angle. Unless otherwise noted, we want to round that angle to the nearest whole number, or whole degree in this case. So notice 36.8 would round to 37 degrees. So theta equals 37 degrees. let's get another one. Sorry, let's adjust and move over. Now here is one. If we're lucky enough to be a pilot, it says the angle of depressions are often used in aviation. Imagine that you are flying into an airport. Your angle of depression is 7 degrees. So as we are this pilot and we're flying in, our angle of depression is 7 degrees. And through our instruments, we know that we are 4,000 feet above the ground. How far do we have to fly before we land? Now, think about how you fly. We're not going to fly. We are flying in this direction, but we don't just fly straight across and then drop down. We are actually flying at a descent in this direction. So in this case, we would be looking for x. Now recall that an angle of depression is the same as if we were down here at this airport trying to make our runway, would be the same as our angle of elevation. And if we have these parallel lines with the horizontal, right, then we have alternate interior angles. So therefore, this is a 7-degree angle as well. So let's clean this up and let's look at it. That means we have our right triangle here. That's horrible, but it's a right triangle. This is a 7-degree angle, and we are looking for x. So let's set up what we know. In relationship to our angle, this is our opposite side, this is our adjacent, and this is our hypotenuse. So we're given the two values of opposite and hypotenuse. So that is the sine of 7 degrees equals opposite of 4,000 divided by h, or I'm sorry, it's our hypotenuse, which is x. Now, we can solve this ratio, understand everything's over 1, but also remember that as we're solving ratios, we can, as we multiply, we can cross or we can switch. So therefore, x is equal to 4,000 divided by the sine of 7. Plugging that in our calculator, we're going to have 4,000 divided by the sine of 7 degrees. And we get an answer of 32,822 degrees. So how far is it until we land? 32,822 feet. 32,822 feet and some inches. We're going to round to the nearest whole number here. Now, if this problem happened to say how far, it says how far do you have to go before you land? Well, we don't know exactly how far that is. What if it says in miles? We can have a reference of that better. We have to convert that. Since there are 5,280 feet in a mile, we would take this amount of 32,822 and divide that by 5,280. And that would give us our distance in miles. So 32,822, 32,822 divided by 5,280 feet. That tells us that we are approximately 6.2 miles away. We have an understanding of how far that is. So I hope that this lesson has improved your knowledge a little bit of your sine, cosine, and tangent. I just want to recall you back to the things here at the beginning, that an angle of elevation is the same as the angle of depression, depending on the orientation of where you're looking. So if we're here at the top and we're looking down, it's an angle of depression. If we're here at the bottom looking up, it's an angle of elevation. And they are always going to be the same measure.
Then, an angle of elevation is the angle formed by horizontal line and the line of sight to the point above the line. In the diagram, angle 1 is the angle of elevation from the tower T to the plane P. An angle of elevation is the angle formed by horizontal line and the line of sight to a point above the line. In the diagram, angle 1 is the angle of elevation from the tower T to the plane P. Angle of depression is the angle formed by horizontal line and the line of sight to point below the line. Angle 2 is the angle of depression from the plane to the tower. Angle 2 is the angle of depression from the plane to the tower. Since horizontal lines are parallel, then angle 1 equivalent to angle 2. Angle 1 equivalent or equal angle 2 pi alternate interiors angle theorem. Therefore, the angle of elevation from one point is congruent to the angle of depression from the other point. The angle of elevation from one point is equal to the angle of depression from the other point, which means angle 1 must be equals angle 2. Classifying angles of elevation and depression. Classify each angle as an angle of elevation or an angle of depression. You have to try with yourself to classify the angles. Angle A. Is angle A angle of elevation or depression? Try to answer with yourself. You have your time. Again, is angle A angle of elevation or angle of depression, and why? Why angle 1 is angle of elevation or angle of depression? Now we have the answer. Angle 1 is formed by horizontal line and the line of sight to the point below. This is an angle of depression. Angle 1 is an angle of depression. Another one is angle 4 is an angle of elevation or angle of depression. Is angle 4 is an angle of elevation or angle of depression? Take your time and think. Is angle 4 is an angle of elevation or angle of depression, and why? Now we have the answer. Angle 4 is formed by the horizontal line and the line of sight to point above. To point above the line is an angle of elevation. Then angle 4 is an angle of elevation. Another one. Use the diagram above to classify each angle as an angle of elevation or angle of depression. Justify your answer. Justify your answer. Why? About angle 5. Is angle 5 is angle of elevation or angle of depression? Is angle 5 is an angle of elevation or angle of depression? Angle 5 is formed by the horizontal line and the line of sight to point below the line. Angle 5 is formed by horizontal line and the line of sight to point below the line. It is an angle of depression. Angle 5 is an angle of depression. What about angle 6? What about angle 6? Is angle 6 is an angle of elevation or angle of depression? Is angle 6 is an angle of elevation or angle of depression? Now we have angle 6 is formed by the horizontal line and the line of sight to point above the line. Angle 6 is formed by horizontal line and the line of sight to point above the line. It is an angle of elevation. Angle 6 is an angle of elevation, while angle 5 is an angle of depression. Angle 5 angle depression because it joins between the horizontal line and the line to the point below the line, while angle 6 is an angle of elevation because it joins between the horizontal line and the point above the line. The settle space needle casts 67 meter shadow if the angle of the elevation from the tip of the shadow to the top of the space needle is 70 degree. How tall is the space needle round to the nearest meter? How tall is the space needle round to the nearest meter? Firstly, you have to draw a sketch to represent the given information. Let A represent the tip of the shadow, A is the tip of the shadow, and B the top of the space. Let Y the height of the space. A. You are given the side adjacent to angle A, and Y is the side opposite to angle A. So write the tangent ratio. We have the side adjacent to angle A 67 meter and the side Y opposite to the angle A, so we have the tangent ratio. Tan 70 equals Y over 67. Tan 70 equals Y over 67. Multiplying both sides by 67, we have Y equals 67 tan 70. Y equals 67 tan 70. Simplify the expression. Y equal approximately 184 meter. Y equals about 184 meter. If the plane is at an altitude 3,500 feet and the angle of elevation from the airport to the plane is 29 degrees, what is the horizontal distance between the plane and the airport round to the nearest foot? You are given the side opposite to angle A. We have the side opposite to the angle A, 3,500 feet, and X is the side adjacent to angle A. So we have right tangent ratio. We are given the side opposite to the angle A, and X is the adjacent to angle A, so we have the tangent ratio. Tan 29 equal 3,500 over X. Multiply both sides by X and divide by tan 29. We have X equal 3,500 over tan 29. Simplify the expression. We have X equal 6,314 feet. Another one. Try to answer with yourself. Draw sketch to represent the given information. We have 115 is the adjacent to angle B. 52 angle, which angle C will equal angle B. Then measure angle B equals 52 degree. By writing tangent ratio, we have tan 52 equals Y over 115. Multiplying both sides by 115, we have Y equal 115 tan 52. Simplify. We have Y equal 147 feet. Another one. Ranger sees another fire and the angle of depression to the fire is 3 degrees. What is the horizontal distance to the fire round to the nearest foot? Measure angle F equal 3 degrees. Measure angle F equal 3 degrees. Then by writing tangent ratio, we have tan 3 equal 90 over x. Tan 3 equals 90 over x. Multiplying both sides by x and divide by tan 3, we have x equal 90 over tan 3. Simplifying the expression, we have x equal 1717 feet. An observer in the lighthouse 69 feet above the water. He sights two boats in the water directly in front of him. The angle of depression of the nearest boat is 48. The angle of depression to the other boat is 22. What is the distance between the two boats round to the nearest foot? By sketching the diagram, we have the distance CA is called y, the distance AB, which is the distance between the two boats, is called x, the distance CB is called z. First, we have to find y. Angle CAL in our diagram will equal 58 degree. Then tan 48 equals 69 over y. So y equals 69 over tan 48 equals 62.1 feet. Finding z from the other triangle, we have angle CBL equals 22 degree. Then tan 22 equals 69 over z. So z equals 69 over tan 22 equals 170.8 feet. Find x. X is the difference between z and y. X equals the difference between z and y, which equal 170.8 minus 62.1 equal 109 feet. So the two boats are about 109 feet. Pilot flying at an altitude of 12,000 feet flies to airport directly in front of him. The angle of depression to one airport is 78 and the angle of depression to the second airport is 19 degree. What is the distance between the two airports round to the nearest foot? By sketching diagram, we have AC equals y, AB equals x, and BC equals z. Firstly, we have to find y. Angle CAB equals 78. So tan 78 equals 12,000 over y. 12,000 over tan 78. So y equal 2,551 feet. Finding z. Angle CBB equals 19 degree. So tan 19 equal 12,000 over z. Z equal 12,000 over tan 19 equal 34,851 feet. To find x, x equals the difference between z and y. So x equals 34,851 minus 2,551 equal approximately 32,300 feet. So the two airports are about 32,300 feet. Classify each angle as an angle of elevation or angle of depression. Classify each angle as an angle of elevation or angle of depression. Take your time, then try to answer. Take your time, then try to answer. Classify each angle as an angle of elevation or angle of depression. Angle 6 is an angle of depression, while angle 9 is an angle of elevation. Plane is flying at an altitude of 14,500 feet. The angle of depression from the plane to the control tower is 15 degree. What is the horizontal distance from the plane to the tower round to the nearest foot? Another one. Woman standing 12 feet from the